Tutorial number 2, question number 1. It is a pinball game and it has initial speed of 3 meters per second at time t is equal to 0. What we need to find is the acceleration at time is equal to 0.08 and 0.2 seconds. The speed of the pinball has decreased by 10% from the initial value, and this decrease may be assumed to occur uniformly from the total distance traveled by the pinball. You might think the speed of pinball decreases uniformly means the acceleration of the ball is constant. However, that is wrong. If you take a look at the diagram, the direction of ball has changed, but the tangential acceleration is constant. We can draw a diagram right here. In this case, the normal acceleration comes from the spot of runway, and the tangential acceleration comes from the friction. So the condition given is actually the magnitude of velocity changed uniformly, because normal acceleration is always perpendicular to tangential acceleration and direction of motion. It just changes the direction of velocity instead of the magnitude of it. In other words, the ball is occurring rectilinear motion in tangential direction. So let's collect all the conditions. So we have initial acceleration 3 meters per second. R is equal to 150 millimeters, which is equal to 0.15 meter. And Vf equal to 0.9 VA to 2.7 meter per second, and theta is equal to 60 degrees. We need to find the acceleration at 0.08 seconds and acceleration at 0.2 seconds. We have to get the distance of the whole runway. So SAF is equal to 3R plus R pi over 2 plus theta to 3 times 150 plus 150 times pi over 2 plus pi over 3, which is equal to 0.843 meters. As I said, is rectilinear motion in tangential directions, so we can use our formula set. The first is Vf squared minus Va squared, which is equal to negative 2A TSAF. 2.7 square minus 3 square equal to a negative 2 AT 0.843. AT is equal to 1.015 meter per second square. When T1 is equal to 0.08 second, we need to find the location of the ball when t is equal to 0.08 second. V1 is equal to VA minus AT to 3 plus negative 1.015, 0.08, which equal to 2.92 meter per second. S1 is equal to VAT minus 1 over 2 AT T1 square, 3 times 0.08 minus 1 over 2 times 1.015 times 0.08 square equal to 0.237 meter. SAC is equal to R plus pi over 2 R to 0.15 plus pi over 2 0.15, which is equal to 0.386 meter. SAB is equal to R, which is equal to 0.15 meter. Because SAB is smaller than S1, is smaller than SAC, so we could say the ball is in the first curve. So we can draw a diagram to show the location of the ball. And here is his velocity. Here is his tangential acceleration. Here is the normal acceleration right here. We set this to C, and this is Cartesian coordination. So we could say S1 is equal to 0.237, which I got it before, is equal to R plus RC1 equal to 0.15 times 1 plus C1. C1 is equal to 0.58 radian. We can transfer it to degree by times 180 over pi, which is equal to 33.1 degrees. So A1 normal acceleration is equal to v1 square over r, which is equal to 2.92 square over 0.15, which is equal to 56.8 meter per second square. So we need to put the acceleration into our xy coordination. So we would say A1 is equal to normal acceleration sine C1 negative A1 tangential cosine C1 I plus normal acceleration cosine C1 minus A1 tangential sine C1. After we solve this equation, we got 31.9 I plus 47 J meter per second square. Again, when T2 is equal to 0.2 second, we need to find the location of the ball again. Then V2 is equal to VA minus AT T2. 3 minus 1.015 times 0.2 equal to 2.8 meter per second. S2 is equal to VA times T2 minus 1 over 2 AT T2 square. Oops. T2 square. Which we have is 3 times 0.2 minus 102 times 1.015 times 0.2 square equal to 0.58 meter. SAD is equal to R plus SAC equal to 0.15 plus 0.386 equal to 0.5 36 meter. SAE is equal to SAD plus R theta to 0.536 plus 0.15 times pi over 3 equal to 0.693 meter. Because SAD is smaller than S2, smaller than SAE, we could say the bore is in the second curve. Then we need to draw the diagram again. Here is the normal acceleration. Here is the tangential acceleration. Here is the velocity. We set this to C2. Again, we need to use C2 to transfer it back to the Cartesian coordination. So S2 is equal to 0.58 meter, which I got it before. 2r plus r pi over 2 plus C2. Then we have 0.58 is equal to 2 times 0.15 plus 0.415, 4 plus C2. Then C2 is equal to 0.29 radian, equal to 16.84 degree. Again, a normal acceleration is equal to v2 square over r, which is equal to 2.8 square minus 0.15, which is equal to 52.2 meter per second square. Then A2 is equal to A to n cosine C2 minus AT sine C2 I minus A to n sine C2 plus 2 tangential cosine C2 J, which is equal to 49.6 I minus 16.8 J meter per second square. Question number 2. We need to determine the vertical rise edge of the load W when the hoist is working. So let's calculate all the given conditions right here. We have the T is 10 seconds for the whole period, and if we divide the point as the end of cable, we named A. Then we have velocity of point A is equal to 180 millimeter per second. What we need to find is rise h. The main point to solve this kind of problem is to determine how many cables we have and what's the length of these cables. We have 2 cables in this case. Here's our cable number 1 and here's our cable number 2. We need to define zero distance right here. Here is our SA, here's our SB, and here's our S weight. We define this this distance is to calculate the length of the cable. The first cable, by the way, if this part really bother you, you can just name it constant 0, but it doesn't matter. The first cable, SA plus 3SB minus 2C0 is equal to a constant. We call it C1. We can put it right to the right, equal to 3, 2. We have second cable, is equal to 2 SW minus SB is equal to constant 3. Take the derivative of these two equations with respect to time. We have VA plus 3VB is equal to 0. 2 VW minus VB is equal to 0. Solve these two equations. We have VW is equal to negative 104 VA. SW is equal to VWT is equal to negative 106 times 180 times 10 is equal to negative 300 millimeter. So H is equal to 300 millimeter. Question number 3. The slider P moved inward by the means of the string S, while the slotted arm rotated about the point O. So what we need to find is the acceleration of the slider when time is 4 seconds, and also the acceleration. And the direction of it should be expressed by the angle alpha relative to the x-axis. We call this alpha v, alpha acceleration. What we have is the form of theta, expression of theta is 0.8 t minus t squared divided by 20. R initial is equal to 1.6 meter, and also velocity inward is equal to 0.2 meter per second. We already have the expression for theta. We can take the time derivative of it. Oops. Minus 0.1 t. And we can get the angular acceleration by derivative again, which is negative 0.1. As for r is equal to 1.6 minus 0.2 times t. Time derivative of r is equal to negative 0.2. Again, the acceleration is equal to 0. When t is equal to 4 seconds, we have theta is equal to 2.4 radian. Angular velocity is equal to 0.4 radian per second. And r is equal to 0.8 meter. So this question is very suitable for the polar coordination. So we have the expression for velocity, which is r dot er plus r theta dot e theta. It's 0.2 er minus 0.8 times 0.4 e theta, which is equal to negative 0.2 er plus 0.32 e theta meter per second. We can get the magnitude of it by square root, equal to 0.377 meter per second. We also need to find the direction of it, which is alpha. We can draw a diagram of it. First is our Cartesian coordination, xy, and here's our polar coordination. here's ER, here's E theta, and here's our V, we can call V. And we can name that as beta. So beta is equal to inverse tangent 0.2 over 0.32, which is equal to 32 degrees. So alpha, we can see from the diagram, is equal to beta plus theta plus 90 degrees, which is equal to 32 plus 0.5 plus 90 is equal to 260 degrees. As for acceleration, we also have an expression. So we can put all the value we have into it. We will get acceleration is equal to negative 0.128 ER minus 0.24 E theta. Again, we can get the magnitude of it equal to 0.272 meter per second square. We need to draw another diagram. Here's our A, and here's the ER, here's E theta. So we can draw it, project to the E theta direction. We call it beta. And here's our AR. Here's our A theta. So alpha is equal to theta minus 90 degrees minus beta, which is equal to 19.44 degrees.